Information is given about a polynomial function f of x, whose coefficients are real numbers. Find the remaining zeros of f. We know that this polynomial is of degree 3, and we have identified already two zeros of this polynomial function, 5 and 6 minus I. So we're going to use the conjugate pairs theorem to identify the remaining zero. There is only one remaining zero because of the fundamental theorem of algebra. This polynomial is of degree 3 and will have at most 3 zeros. So we already have two zeros. There's only one remaining zero. The conjugate pairs theorem says that let f of x be a polynomial function whose coefficients are real numbers if r equals a plus bi is a zero of f. So we have a zero that is a complex number. The complex conjugate a minus bi is also a zero of f. So what this theorem tells us, as long as we have a polynomial function with real coefficients, if we've identified one complex zero, the conjugate of that complex zero is also a zero. So we do have one complex zero, 6 minus I, and the conjugate of that zero would be 6 plus I. So 6 plus I is the remaining zero of this polynomial function. Form a polynomial function with real coefficients having the given zeros, given degree and given zeros. The degree is 4, and the zeros are 1 with multiplicity 2 and 4i. So we notice that we have a polynomial of degree 4, and the fundamental theorem of algebra tells us that we have at most 4 zeros. So we have a zero of 1, and it's stated that it has a multiplicity of 2. When a polynomial has a zero of 1, that means that it has a factor of x minus 1. And the fact that this has a multiplicity 2 means that we have another factor of x minus 1. Then we notice that we have a complex zero. We have a complex zero of 4i. And as long as our polynomial function has real coefficients, we can use the conjugate theorem the conjugate pair theorem to state that we also have a zero of negative 4i, the conjugate of 4i. So that means that we have, for the zero of 4i, a factor of x minus 4i, and for the zero of negative 4i, we have a factor of x plus 4i. We're going to use these factors to form the polynomial. So our polynomial function f of x will be a. A is an unknown leading coefficient because there are many polynomials that will fit this description, and so we're leaving that value of a unknown. And we have a factor of x minus 1, another factor of x minus 1, a factor of x minus 4i, and a factor of x plus 4i. I'll start to simplify this by multiplying, and I always like to multiply the conjugate pairs together because they form really nice expressions to work with. And I'll also multiply x minus 1 times x minus 1. So that would give x squared minus x plus 1. And if I multiply these conjugate pairs together, that becomes x squared minus 4ix plus 4ix minus 16i squared. I'll combine like terms, and this gives x squared minus 2x plus 1 minus 4ix and plus 4ix cancel each other out. I squared is defined to be negative 1. And negative 16 times negative 1 is a positive 16. So we have x squared plus 16. And then we'll multiply these two expressions together. So I multiply x squared times both of these terms, and that will give x squared times x squared plus 16. And then I'll multiply minus 2x times both of these terms, minus 2x times x squared plus 16. And then finally I'll multiply 1 times both of these terms. That's 1 times x squared plus 16. I'll use the distributive property to get x to the 4th plus 10x squared minus 2x cubed minus 32x plus x squared plus 16. Let's see if I have any like terms I can combine. And I have 2x squared terms, and I'll combine those like terms and also write these terms in descending order. So that's x to the 4th minus 2x cubed plus 11x squared minus 32x plus 16. So we form the polynomial with zeros of 1 and multiplicity 2, and zeros of 4i and negative 4i. So I'm going to come back and make a correction, and I'm going to highlight the mistake that I made here. The mistake that I made was in being a little bit sloppy and copying down my numbers. So I want you to notice right here that this is supposed to be a 16, but as I was sloppily writing it, it looked like a 10. So I need to make this correction. So this number here would be a 16. And that means that when I combine like terms, instead of this being 11, this would be 17, 16 plus 1. So the polynomial function is x to the 4th minus 2x cubed plus 17x squared minus 32x plus 16. Thank you for checking out my videos. Have a great day.